Hi, my name is Nixie, and I will be doing the balancing equations chemistry lab for Chemistry 1406. Let's get to it. For this lab, we're going to need the basic chemistry modeling set and the balance equation mat and a dry erase marker so we can write on the mat. For the preparation of this lab, you need to separate all of the atoms into their respective colors. So you will need 8 red 4-prong atoms, so 1, 2, 3, 4. And then you're going to need 4 blue 4-prong atoms, 6 green for one-sided prong atom. There are these green ones that are 4 prongs, and then you need 20 of the white 1-prong atoms, and there are also a few of these, so the one-sided ones you need, and then you need 4 of the yellow 1-prong atoms. So according to our first step of the activity, we need to write down the colors, or the respective colors to the equation that we'll be using, and the colors that we're going to be using for this first problem is white, blue, green, and red, which will be written in under the tally table in the color box right here for sodium, and red would be for oxygen. Our next step would be to assign the color to a symbol, and white would be for hydrogen, blue would be for chlorine, green. So the first equation given to us is HCl plus an AOH then turns to an ACl plus H2O, 2 being a subscript, and no coefficients are given, so we must balance the equation, which turns to 1, 1, 1, 1. Now, if we make models with the model kit, we do get this for the first one. So if we look down here, the H is white, so 1 white, and then in blue for chlorine, 1 blue. If we go to this one, right here, put that in there, you get 1 red for oxygen, 1 white for hydrogen, and 1 green for sodium. Now if we come on this side, you get 1 blue for chlorine, and 1 green for sodium. And lastly, you get 1 red for oxygen and 2 hydrogens for white. So if we look at the equation, you see that there are 2 whites on this side, 1 blue, 1 red, and 1 green. And then on this side, you have 1 blue, 1 red, 1 green, and 2 whites. And that's where you tally these, number of atoms on left side, number of atoms on right side. And that's how you learn how to balance them. So if you do 1 H, so that's 2, 1 times 2, 2 hydrogens, 1 times O, 1 oxygen. Same thing for here, 1 times Na equals 1 sodium, and then 1 times Cl, 1 chlorine. And that's how you get to balance a balanced equation. This should be the final product for this first example given to us. So we're going to do one other example, and for this equation we're going to do 1 Mg magnesium, 1 hydrogen, and 1 chloride, and then we're going to do magnesium plus hydrogen 2, subscript, remember, little numbers are subscripts, and then hydrogen 2, so subscript. And then what we're going to do, we're going to color assign them. So white is going to be for hydrogen, green is going to be for magnesium, and yellow is going to be for chloride. So the next step would be to tally mark them. So currently we have 1 green for magnesium, 1 yellow for chloride. Ignore the 2 currently right now, and then 1 white for hydrogen. Ignore the other 1 as well. And then on this side we have 2 yellows, so 2 chlorides, 1 magnesium green, and 2 hydrogens. Since we do need to balance these equations out, we notice that there are 2 yellows. So if we go to yellow, that is for chloride. And on this side, there is 2. And currently, we only have 1. So we go up here, and we're going to do 2 times 2 right here. So it's going to have, add a yellow. So now it's 2, which also means we bring up the total to 2 whites, which brings up 2 here. And that also matches the 2 on this side. So everything's equal to 2, 1, 1, 2, 2. And that's when we bring in another one. So this is how the finished results should look. The final product is green, 1, 2 yellows, 2 whites on this side, and then 2 yellows, 1 green, and 2 whites on this side. And it is a perfectly balanced equation. Thank you.